An arc fault circuit interrupter, known as an AFCI, is a type of circuit breaker that is designed to detect electrical arcs, which are dangerous unintended electrical discharges. AFCIs are intended to protect against fires caused by arcing faults in electrical wiring. Now considering a 14/3 circuit, it contains a black wire, a red wire, a white wire, and a bare ground wire. The black and red wires are hot wires, each carrying 120 volts in a standard residential electrical system. The white wire is the neutral wire, and it provides the return path for the current. The bare ground wire is the grounding conductor, which provides a path for fault current to return to the source, tripping the circuit breaker or AFCI and clearing the fault. In a multi-wire branch circuit, or shared neutral circuit, two hot wires share a common neutral wire. This configuration can save on wiring costs, but it also presents some unique challenges for AFCI protection. The question is whether two single-pole AFCIs can be used on a 14/3 circuit with two 15-amp circuits sharing the same neutral, or whether a two-pole AFCI is required. The answer is yes, two single-pole AFCIs can be used on a 14/3 circuit with two 15-amp circuits sharing the same neutral. A two-pole AFCI is not required in this situation. Each hot wire can be protected by a single-pole AFCI. The neutral wire is connected to the neutral busbar in the electrical panel. When an arcing fault occurs on either of the hot wires, the corresponding single-pole AFCI will trip, interrupting the circuit and preventing a fire. The National Electrical Code, NEC, provides the requirements for AFCI protection. Section 210.12 covers arc fault circuit interrupter protection. This section requires that all 120-volt, single-phase, 15-amp and 20-amp branch circuits supplying outlets or devices installed in dwelling units be protected by AFCIs. An exception to this rule is that AFCI protection is not required for branch circuits that supply only a fire alarm system. AFCIs are designed to detect different types of arcing faults, including parallel arcs, which occur between two conductors, and series arcs, which occur in a single conductor. AFCIs also have sophisticated algorithms to distinguish between normal arcing, such as that which occurs when a switch is opened or closed, and dangerous arcing faults. There are several types of AFCIs available, including branch/feeder AFCIs, which protect the entire branch circuit, and outlet branch circuit AFCIs, which protect the branch circuit downstream from the AFCI. Combination AFCIs provide both branch/feeder and outlet branch circuit protection. When installing AFCIs on a shared neutral circuit, it is important to ensure that the neutral wire is properly connected to the neutral busbar in the electrical panel. A loose or disconnected neutral wire can cause a variety of problems, including voltage fluctuations and equipment damage. It is also important to ensure that the AFCIs are properly sized for the circuit. A 15-amp AFCI should be used on a 15-amp circuit, and a 20-amp AFCI should be used on a 20-amp circuit. Using an AFCI that is too small for the circuit can cause nuisance tripping, while using an AFCI that is too large for the circuit can reduce its effectiveness. When selecting AFCIs, it is important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories AL. Listed AFCIs have been tested to meet specific safety standards and performance requirements. In addition to AFCIs, ground fault circuit interrupters, GFCIs, are another type of protective device that is used to prevent electrical shock. GFCIs detect ground faults, which occur when current flows through an unintended path to ground. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. While AFCIs protect against arcing faults, GFCIs protect against ground faults. These are two different types of electrical hazards that require different types of protection. In summary, two single-pole AFCIs can be used on a 14/3 circuit with two 15-amp circuits sharing the same neutral. A two-pole AFCI is not required in this situation. AFCIs are an important safety device that can help to prevent fires caused by arcing faults in electrical wiring. It is important to install AFCIs in accordance with the NEC and to ensure that they are properly sized and installed. Always consult with a qualified electrician when working with electrical wiring. They can help ensure that your electrical system is safe and up to code. They can also answer any questions you may have about AFCIs or other electrical safety devices. One important aspect of shared neutral circuits to keep in mind is the potential for overloading the neutral conductor. In a standard 120-volt circuit, the neutral conductor carries the same amount of current as the hot conductor. However, in a multi-wire branch circuit with two hot conductors sharing a neutral, the neutral conductor can potentially carry up to twice the current of each individual hot conductor. The NEC addresses this issue in section 310.15, which provides requirements for conductor ampacity. The code requires that the neutral conductor in a multi-wire branch circuit be sized to carry the maximum unbalanced load. The unbalanced load is the maximum difference in current between the hot conductors. For example, if one hot conductor is carrying 10 amps and the other hot conductor is carrying 5 amps, the unbalanced load is 5 amps. In this case, the neutral conductor would need to be sized to carry at least 5 amps. However, in many cases, the neutral conductor is sized to carry the same amount of current as the hot conductors. This is because it is often difficult to predict the exact unbalanced load. In addition to the requirements for conductor ampacity, the NEC also has requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating due to excessive current. The NEC requires that overcurrent protection devices be sized to protect the conductors they supply. This means that the overcurrent protection device must be rated to carry at least the ampacity of the conductor. In a multi-wire branch circuit, each hot conductor must have its own overcurrent protection device. The neutral conductor does not need its own overcurrent protection device, but it must be sized to carry the maximum unbalanced load. When installing AFCIs on a multi-wire branch circuit, it is important to ensure that the AFCIs are compatible with the circuit. Some AFCIs are designed to be used on multi-wire branch circuits, while others are not. It is important to check the manufacturer's instructions to ensure that the AFCI is compatible with the circuit. Another important consideration is the potential for neutral current to flow in the ground conductor. This can occur if there is a ground fault in the circuit. If neutral current flows in the ground conductor, it can cause the AFCI to trip. To prevent this from happening, it is important to ensure that the ground conductor is properly connected to the grounding electrode system. The grounding electrode system is a network of conductors that are connected to the earth. The grounding electrode system provides a low impedance path for fault current to return to the source. This helps to ensure that the AFCI will trip quickly and clear the fault. In addition to the NEC requirements, there may also be local codes or ordinances that apply to electrical wiring. It is important to check with your local building department to determine if there are any additional requirements that apply in your area. Finally, it is always a good idea to have your electrical work inspected by a qualified electrical inspector. An electrical inspector can ensure that your electrical wiring is safe and up to code. They can also identify any potential problems that you may have missed. In conclusion, using two single-pole AFCIs on a 14/3 circuit with a shared neutral is permissible and compliant with the NEC. However, proper installation and understanding of the circuit's characteristics, including potential unbalanced loads and grounding, are crucial for ensuring safety and optimal performance.